Good morning to everyone. Welcome back to the class Linear Equations in Two Variables Part 11. As we discussed, there are 11 parts in this video and this is the last part. And this is a summary part. In the last video, we practiced one more example for plotting the solution as a unique solution on the number line and multiple solutions on the Cartesian plane. Hope all of you have understood the difference between linear equation one variable and two variables. This video will summarize the entire chapter. Three main aspects we have learned. That's what we have been discussing in the beginning. So now note down, pause this video and note down what three main aspects you have learned in this chapter, and then you see whether what I have written and what you have written are same. Yes, I am sure all of you would have written the same three what I am going to write. So we have understood what is linear equations in two variables. We have understood how to find solutions for linear equations, and we have also learned graph of linear equation, how to plot a graph of linear equation. Now let us see. Now from this page onwards, what did we learn in this chapter? I am going to go a little fast. I am only going to show the paragraphs. This is nothing but every video in the last page we have seen one page, that is what did we learn in this video. I have reproduced the same thing and the same bold everything is there. So you need not also go through in detail all these. Whenever you have doubt, you can come to this particular part of the chapter and then you can understand. Like for example, if you have doubt what is linear equations in one variable, you can easily see immediately. Even the bold, whatever is there in the bold font, if you see that, that is more than sufficient. So like this, every page after it is over, you can pause the video for a few seconds and then see if you want to understand or learn something, and then go to the next part. Okay, this is the second aspect, solutions for linear equations. Even the notes also, whatever you saw as the notes in that particular part, I have brought it here. Three graph of linear equations. Again note. That's it. This is what we saw in the last paragraph. You see, that is what we saw in the beginning of this video also. The same we learned in the last part. Now, what is the need for studying linear equations? This is what we saw in the beginning of this chapter, that this also we will be discussing. We already discussed that in linear equations, two variables, if we solve for two sets of values, plot these as coordinates in the Cartesian plane and join them to form a straight line, we can find infinite sets of values. This means that for any given value of one variable, we can find the value of other variable without requiring to solve the equation. This will help in certain decision making also. The above is applicable for linear equation one variable also, like we can put the other variable as multiplication factor of 0 and find it. So in the next page, we are going to see a practical example. In a village, there are 5 families, each family comprising of a child, her mother and father. So there is one daughter and her father and mother, 3 persons in a family, and there are 5 families, totally 15. Kalpana is a volunteer. She wants to do Narayan Seva for an amount of rupees 3000. She wants to give dresses to all. Like you may be knowing, like Gram Seva, which our Sai Krishna Charitable Trust does, Sai Krishna Charitable Trust also does Narayan Seva. This year they did Narayan Seva in nearby villages, where they went and distributed some gifts to the people. So here Kalpana is a volunteer as a part of Sai Krishna Charitable Trust. She wants to, not as a part of Sai Krishna Charitable Trust, like this she also wants to do Narayan Seva from her own money. 3000 rupees she wants to spend, and she wants to give dresses to all the 15 people. She goes to a shop and finds the prices as ranging from 100 to 600. It could be 100, 200, up to 600 she can give. She makes a linear equation. Very good, no? So see the practical use. For just buying a dress, she has made a linear equation 5x plus 10y equal to 3000. where X is the price of child's dress and Y is the price of each parent's dress. Just carefully listen to this paragraph. This is very important, and probably you would have also learnt in the algebra lessons, that is, in wherever the unknown factor, that is, what is the price of a child's dress and what is the price of a parent's dress, we don't know. So we have assumed the variables as X and Y, but we know the quantity. That is, for this situation, remember what we discussed in this chapter also. This situation, 3000 is fixed. The 5 number of children are fixed. 10 number of parents fixed. But we don't know the value of each dress. That's what we don't know. And the each dress value, that is, child's dress will be same, all 5 children's dress, as well as all 10 parents' dress will be same. So 5x plus 10y equal to 3000 is the equation. Now we are going to draw a graph for this. So she made a Cartesian plane. Since this is only positive, the values are all positive, negative axes are not shown. The most important first thing, scale. Yes, now you can see if it is 1 unit equal to 1 rupee, then there is no place in our notebook. In any paper also it will not be available. So she has assumed 1 unit equal to 100 rupees for both x-axis and y-axis. That's what we discussed earlier. Even if both are same, both the axis measurements are same, it is better to put the scale so we will know what is the value of each unit. And the next step, yes, good, we have to name the axis, and the measurements also we already made. Yes, so on this graph, without seeing anything else, any other page, you will be able to understand various things which we are going to see now. So now the steps start. First step is ordered pairs. Next step is table. Third step I am going to plot. So the first ordered pair is 0, 300. That is, if the child's dress is 0, the value of parent's dress is 300 rupees. And if the child's dress is 600 rupees, the value of parent's dress is 0. Now drawn the graph, remove the equation from there and put it here. Then cross checking. If the child's dress is 100, the parent's dress is 250 rupees. So now the equation is correct, the graph is correct. Now what is the next step? Yes, next is, now there are no steps, but Kalpana also has a policy. She also decides one more thing, that is, each child's dress should be twice the value of the parent so that it gets balanced. That is, if a child's dress is 200 rupees, then the parent's dress should be 100 rupees. Now she is going to, so one way is substitute each and every value. If I put x equal to 200, 5 into 200, 1000, 3000 minus 1000, 2000, then 2000 by y equal to 100. So like this, one by one, if she wants to do it, will take a long time. So she starts plotting here. Okay, she thought maybe if it is 150 rupees of child's dress, then what is the value of parent's dress? She draws a line. From the graph you are able to make out. Are you able to understand this? Yes. So if child's dress is 150 rupees, that is x coordinate, and y coordinate is 225 rupees, that is parent's dress. So this is not correct. Now she assumes, okay, let it be 400 rupees child's dress. Then what is the value of parent's dress? It is coming to 100 rupees. No, again this is also not acceptable. It cannot be 4 times. Okay, she assumes one more value. Let it be 300 rupees. And she finds that, yes, 150. Just I am marking this circle. So now you are able to see, without solving the equation for each and every assumed value of x, from the graph we can find out the value of y. The reason is, this line will have all the solutions of linear equations of 5x plus 10y equal to 3000. And how many solutions? Infinite number of solutions. So by careful observation we will be able to find out which meets our requirement. Suppose the reason is, suppose now we want x equal to y. Instead of both double, that is, if child's dress should be twice the value of parent's dress, then it is 300 and 150. Suppose both are to be same. Okay, let us see in the next page these things. So now if you have doubt, you can just pause the video, note down this graph. This graph is a very useful practical example graph which you can also use for any your own purchases, or you can help your parents to take decisions. Let's go to the next page and see. So this whatever I have told, it is written here. So by careful observation, close observation, we will be able to find out what is the actual requirement, which solution meets our requirement. So depending on this way, by making a linear equation in 2 variables, finding 3 solutions and drawing the graph, we can take decisions easily. Right, no? So any decision we will be able to take by making a linear equation, plot the solution, 2 solutions or 3 solutions, and then draw the graph. From that we can make out decisions. We'll go to the next page. There is another method called simultaneous equations. Let us see what is that. It is a very simple equation, but we will be learning more in detail in the next class in 10th standard, but not in 9th standard. This is only for your information I am showing. We already have one equation, all of you know. Then the second requirement. What is the second requirement? The price of child's dress should be twice the price of parent's dress. So pause the video and see whether you can write an equation for that. That is anyway useful for linear equations. Yes, I am sure most of you would have got it. It is x equal to 2y. If x is 200, y is 100. That is twice the value of parent's dress will be the child's dress. And now what we are going to do, we are going to multiply equation 2 by 5. We are going to solve this equation and bringing RHS to LHS. We get 5x equal to 10y. I will just show you here. That is, I am multiplying into 5 into 5. What happened? So it became 10x equal to, x equal to 5x equal to, not this, 5x equal to 10y. X equal to 2y is 5x to y. Then I take this to here. So 5x minus 10y equal to 0. Okay, I will remove this. Now after that what I am going to do, it is all written in the next page. Again I will tell here itself so that you will be able to remember easily. Now I am going to subtract equation 3 from equation 1, or we can add also equation 1 plus equation 2, both are same. Equation 3, 1 plus 3 or 1 minus 3. Now I am going to put 1 minus 3, that is this minus this. What is that? It becomes 0. This minus 10y. So what happens? 10y minus of 10y, 10y minus of 10y, 10y minus 10y equal to 20y. And what is that value? Equal to 3000 minus 0 equal to 3000. Are you able to understand? So subtract equation 1 minus equation 3. So 5x minus 5x becomes 0. So x is gone. 10y minus of minus 10y equal to 20y. 3000 minus 0 equal to 3000. So 20y equal to 3000. Therefore, y equal to 3000 minus 20 divided by 20 equal to 150. So let's go to the next page. I will remove all these things. So subtracting, I have written the same, y equal to 150. Substituting y in equation 1, or we can substitute in equation 2 also. All these things you will learn in the next class in 10th standard. We get x equal to 3000. So the answer is child's dress is 300 rupees, not x equal to 300. Parent's dress is 150. So this requirement we have met now. So child's dress is twice the value of parent's dress. So main problem in this method is for every different requirement, equation 2 will change and we have to find a new solution. Suppose you want both dresses should be same. So what you have to do? Now we have to put equation number 2 as x equal to y, and then 5x minus 5x, 10y minus 5y, like this. No, you have to solve the equation as we are doing here in the first 2-3 lines. Whereas in the case of graph, what did we do? We did not do any equation, just kept on plotting the point x value, and we are able to find out what is the corresponding y value from the graph itself. This is the reason I have put. So from graph you can straight away find out, whereas in simultaneous equations you have to make a new equation number 2 and then again multiply equation number 2 by whatever value to make it same as equation number 1 and subtract, add, whatever, we have to do that. That's a long process. However, in graph only disadvantages, up to 2 variables only we can make the graph. Beyond 2 variables only simultaneous equations will be used, and which we will be learning in later classes. So what next? As we have understood that linear equation in 2 variables along with coordinate geometry or Cartesian system or graph will be extensively used in decision making. We will be learning more about these in later classes. So we will be using for practical applications even more, and then see that how these are useful for our day-to-day life, as well as higher levels of maths and science, how these are used will be learnt in the later classes. So in this video we summarize the entire chapter. The next video is not applicable for this particular branch of mathematics, as these are the two chapters, linear equations and coordinate geometry in 9th standard, beyond which only in 10th standard you will see related parts, related aspects of this particular branch of mathematics. And 5 questions, 4 here, I think there are 6. So you see one question number 4, refer practical example of this part. If the price of both childs and parents are to be same, find out the price of each dress from the graph. So you can draw the same graph what you have seen in this example, in this video, and from that you plot. Without writing the equation x equal to y, you should be able to find out what is the value of each child and each parent. That will give you a very good idea that decision making is very useful. For decision making, this graph is very useful. And 2 questions here. And that's all for this chapter. Thank you very much. Hope all of you enjoyed learning this chapter, learning thoroughly, enjoyed listening to me, and I hope that you'll be able to use this last what we saw for practical applications also. And also thank you all for patiently listening to me, and that's all for this chapter. We will see you in the next chapter.